Hello and welcome back. In the previous video, we saw that what is the meaning of binary encoding, what is binary encoding, when to use it, and how does it benefit over the normal encoding, which we saw very first encoding, and that was uh, one hot encoding, right? So compared to one hot encoding, this binary encoding is more efficient because it creates less number of new features when you are encoding the categorical variables. So let us see sample code in Python using the pandas library. So let's see what we need to do. So first of all, I'm just going to create some data, and then I'm loading that data frame in one of the cells. So in this cell, I'm just creating the data. So in the data, we have category like A, B, C. In this data, we have one categorical variable with the name category, and there are values like A, B, C, D, A, B, C, E. So you can see there are 1, 2, 3, 4, and 5. So 5 categories are there. I mean, for this categorical feature, we have 5 categories. There are values for the 5 different categories. So first of all, I'm loading this. So if you see these variables, these values, then there are A, B, C, D, and E. So there are 5 different values for this category. So if you have to represent 5 different values under a category, then how many bits you require? If you use 2 bits, then you can represent only the values between 0 to 3. If you need uh, 4 variables, 4 categories, right? Then in that case, you need to have only 2 bits. But in case you need 5, right? If you have 5, then in that case you need to use 3 bits, right? Because number 5 can be represented using 3 bits, not the 2 bits, right? So 5 values or 6 values or up to 7 values or up to 8 values, you need uh, at least 3 bits, right? I hope you are aware about the bit operations and why we need 3 bits to represent the values between 0 to 7, or you can say the 8 values. And why you need 2 bits if you have to represent the values between 0 to 3, which means 4 categories, right? So here we have 5 categories, so we need to have at least 3 bits, right? So 3 columns will be created. But in case you have used the one hot encoding, then in that case, how many you will create? You will create a matrix, which is an identity matrix of 5 cross 5, right? So obviously 5 new features will be added in your data set, but in this case only 3 new features will be added, right? Because we are using the bits, and each of the bit is representing one new feature. So let us move ahead and let us define the number of bits needed, and number of bits needed, and how many number of unique categories are there. Just to find that, we need to write this piece of code in the next cell. So here I'm going to add a new cell. So let us execute this cell first. And now let us execute this cell, right? So number of bits, if you want to print the number of bits, you can see like how many number of bits it needed. Num underscore bits. So if you run this, you will be able to see that number of bits needed are 3. So how many categories are there? If you see the number of categories, how many categories it has identified, so that also you can print ORIES. And now if you print, then you can see A, B, C, D, E. There are 5 different categories, right? So under this categorical feature, we have 5 different categories, A, B, C, D, and E. And how many bits will be needed? Obviously, we need 3 bits to represent the number between 0 to 5, 0 to 4, right? Because these are 5, so at least 3 bits will be needed. Now come to the next one. So we are creating the binary representation here. So let us see. So we are creating a binary representation. So here we have taken one list for the binary codes, and now inside this category, we are identifying the binary code. So this function bin you need to use, and then you need to fill the number of bits here. So I'm not going to explain these things because this is all about the Python basic programming skills. So you can check these things like what the bin function do and what jetfill do. under the pandas library, and then we are adding the binary codes, right? So these binary codes we are using and appending these binary codes into the binary code list. So this is the binary codes list where we are putting the individual binary codes. And now we are creating the new columns for each bit, right? So because each bit will be representing a new column. So in the range number of bits, whatever number of bits we have used, in that range we are creating number of columns. So we are giving the name of the columns as bit underscore 1, bit underscore 2, because I will be 1, I will be 0, I will be 1, I will be 2, right? In case of 3 bits, right? So it will run 3 times and then it will create a new mapping here, right? So after creating a new mapping here, we can see that what it has created for us, right? So here we are first going to drop the category, the original column we have to drop. So let us go to the next cell. So we are dropping the original category column because we don't need this column anymore, right? This category column we don't need anymore because we have 3 more columns representing this category, right? To represent this category, we already have 3 columns now. So what is the use of this column? There is no need of this column now, right? We have created 3 new features and that we are going to print here. So let me run this one first. And after that, I need to run this one. So if you see, for the column 1, which will be bit underscore 0, then other column will be bit underscore 1, the third column will be bit underscore 2. So for one of the values like A, it could be 000. For B, it is 001. Again, if you come to the 000, fourth number. So at the fourth number, 0, 1, 2, 3, 4, at the fourth number, we again have A. So you can see it here, right? So there are 2 A's. So for A, we have given value 000. Now comes to the B. So here is B and here is B. So at the first number and at the fifth index, we have B. So at the first index and at the sixth index, we have fifth index, we have B. Similarly, we have C. There are 2 C's, right? So this is the C 010. So here also you can see 010. So you can see the mapping here. So similarly, if you take this as some real variable like color, right? If you give the name color and if you give this red, magenta, and then you give green, then you give yellow, then you give red, then for B, magenta, magenta, and then again for C, we are giving as green. And now at the end, suggest me some color pink. Okay. So for the color, we have now these things. So let me put the color everywhere, wherever we have used this category. So here I have to use color. And here I have to drop the color. So now let us run each of the cell. So this cell executing, this cell executed, this cell is obsolete, this also need to be executed. Now come to the last cell, right? So here you can see, rather than bit, I need to give color, right? So we need to run this one first so that I can now, okay, let me run it first. From the beginning, I need to run it. Okay. What is the problem? DF color. Okay, I have given some wrong name. What is happening here? We have given the name color only, right? So let me first run it. Then let me go to this. Okay, so in this second one, I think we are getting a problem. So DF unique number of bits. This is categories. Magenta, green, yellow, pink. Okay, unique categories. We have found it out. Then here, if we come here, then we are getting this thing. So color underscore. Can I give this? Okay, let me put it only bit. I'm not sure what is the issue. There should be something very silly that I'm doing, but yeah, as of now, you can understand that I can give any name here. So rather than bit, I have given color, but still it is not taking it up. So not sure why. So if you come here and if you run it, then you can see like there are three extra columns added. So for each of the color, we have added this thing. So color underscore zero, color underscore, let me try it again. Color underscore this. Okay. What is the issue? Why this is not taking it? Okay, no issue. So if I give, is there any other issue rather than color? I can give color feature underscore feature. Let's see now. Again an issue. Okay, so let me put it like bit. Okay, anyways, let us see bit underscore. Now it is fine. Since the beginning, I need to do it again. Df bit underscore then plus. Okay, no issues. I think there is some silly mistake I'm doing, so no worries. I will check and let you know in the next video. So I hope you must have understood the concept here, what we are doing here. So bit underscore then stri. So not sure what is the issue here, why this is giving an issue, right? So let me try it once again. This is fine. This is fine. But the third one is not fine. We run it again. Yeah, now it is fine. Okay. So bit underscore. So if I do it like color, then what is the issue? Oh, now no issues. Okay. Now if I run it, oh, got it. Great. So here if you see color 0, color 1, color 2. So here you can see these are the ones. Let me run it from beginning so that we only have three columns. We run it. Then let me run it. Okay, now it's good. Color 0, color 1, color 2. Because we are using Jupyter Notebook, so it should have taken the output from the previous cell. That is why it was showing six columns. Now it is showing correctly three columns for each of the bit. Okay, so with this, I would like to say thanks to all of you for uh, being with me. And the mistake that I did, I hope you must have understood here. So there was a silly mistake. I was not running it properly. So not a big issue. There was nothing technical in it. Okay, that was just a silly mistake, a blunder mistake from my side. Thank you. Have a nice day and bye bye.